of momentum. So conservation of momentum. Talks about what happens when objects collide with each other. Okay? Well, I'm going to be very general. What I'm going to say is, first of all, the law itself. What the law states is that in a system, the momentum before a collision always equals the momentum after a collision. That does not mean that individual objects inside the system will have the same momentum before and after. What it means is the system as a whole has to keep the same momentum. Okay? So, if we want to think about that, let's draw ourselves a couple of little shapes here. There we go, some nice circles. And let's imagine that these circles are traveling, we'll say towards one another. They don't have to be traveling towards one another, but let's say they're traveling towards one another. There's circle A, and there's circle B. I want this one to be bigger, because it looks like the other one will just like roll over top of it. You can't have that. So now, these circles can basically have one of two properties, right? They could be in one of two kind of scenarios, right? They could be like really hard steel balls where they would tend to bounce off one another, or they could be like gummy clay balls where they could tend to stick to each other and squash together. So there's two possibilities in this scenario. We don't know yet what the nature of these are. We don't know if they're going to bounce off each other or stick together. If they bounce off, we call that an elastic collision. And if I had a pen in my hand, that would be better. So an elastic collision means, I think so, elastic collision, objects bounce off one another. In a perfectly elastic collision, which is sort of theoretical, the objects don't deform at all. In other words, they just go from traveling one direction to the other direction, if that happens to be what they do, without any energy loss at all. It's just bounce, done. Okay? In a perfectly inelastic collision, they stick together. Can you please write pen? Thank you. Inelastic collision. There's two L's in elastic, right? There's only one? I'm spelling it wrong? No. That was trying to help me and I wasn't listening. There. Perfect. Hope I don't get fired. Yeah, exactly. Objects stick together. Okay. Now, in both cases, whether it's elastic or inelastic, momentum is conserved. Okay. So if we look back at our balls, we'll call this M, we'll call this M, little m and big M. And we'll call this P, and we'll call this big P. So before and after the collision, what we can say is P plus P has to equal P prime plus P prime. So this is before, and that equals after. Now that does not say anything about what P and P prime are or how they relate to each other, just that if I find the total momentum before and the total momentum after, they will be equal to one another. Whether we have an elastic collision and they've bounced off, or we have an inelastic collision and they've stuck together. Now each of these has a V. We'll give this V, we'll give this V. So I'm going to give you a universal equation that describes conservation of momentum. And it goes like this. It says mv plus mv, so this is object 1, this is object 2, equals mv prime plus mv prime. So what are we talking about? Well, this is the momentum of object 1 before the collision. And this is momentum 2 before. And these represent those two momentums after the collision. Okay? Notice that we assume that the mass isn't changing, only the velocities. Okay? So what can you do with this formula? Well, you can figure stuff out. That's what you can do. So for example, a 10 kg ball at 4 meters per second collides with a 10 kg ball at 4 meters per second in the opposite direction. Elastically. Okay. So let's just look at this. Predict the outcome. So basically we have more or less what we did with our carts, but here's our 10 kg ball. It's at 4 meters per second. And here's our other 10 kg ball at 4 meters per second. Remember, velocity is a vector value, so it has a direction. So if we look, the total momentum before the collision is mv plus mv. So mv is 40 kilogram meters per second plus negative 40 kilogram meters per second. Well, our total momentum on the pre-collision equals 0. Then after, since it's elastic, they bounce off one another. So this is after the collision. So you can have one ball going that way and one ball going that way. That's it. So now we've got 10 and we've got 4 meters per second to the left, or negative, and we've got 4 meters per second to the right. This is 10 kgs. What is the total momentum after? Well, we still have, now we have negative 40 plus 40. So that after the collision, well, the momentum still equals 0. Now let's just change one thing. What if it's an inelastic collision now? What if they stick together? So before, we have 10 and 40. Oh, no, that's not right. 10 and 4. And we have 10 and 4 in this direction. Before 0, now if they stick together, they mush together, what's the momentum after the collision if they stick together? 0. Is momentum conserved in both an elastic and inelastic collision? It absolutely is. And that is where we will stop.